Hi everyone, in this video tutorial we are going into a little bit more depth on numbering of the parent hydrocarbon, that is, assigning locants to our longest continuous chain. Now remember, the first process in IUPAC nomenclature, if you're going from structure to name, is identifying the parent hydrocarbon, or longest continuous chain that possesses the highest priority functional group. Then you have to be really diligent about the numbering of that chain. We're going to talk about rules here for numbering. We have 2A, 2B, and 2C, which I've given examples of each down here. We'll talk through those after we denote the rules. 2A is saying that first and foremost, we want to give the lowest locant to the carbon of the highest priority functional group. And if there are multiple of those highest priority functional groups present, then we number the chain overall to give the lowest locant set to those functional groups. So to illustrate that real quickly, 2A, down here you have a functional group compound with an alcohol and an alkane in the molecule. And here's the correct numbering. We will preferentially number the chain to give the carbon bonded to that alcohol the lowest locant. If you numbered in the other direction, notice how you give the alcohol the locant 4. So we want to number that chain to give the highest priority functional group, or alcohol, the lowest locant possible. Here is another example. We have both an alcohol and now an alkene, a carbon-carbon double bond. And the alcohol is higher priority than the alkene, which means we should not number the chain 1, 2, 3, 4, 5, 6, because that gives the alcohol the locant 5. We would want to number in the direction that gives the highest priority functional group, our alcohol, the lowest locant. And of course, in the name, because there is an alkene present, we would also have to denote the presence of the alkene. Okay. Now, alcohols are not the highest overall functional group. Remember, there are higher priority functional groups, say an aldehyde. So the aldehyde now is higher priority than the alcohol. So we ought to number the chain in the direction that gives the carbon pertaining to the aldehyde, that far right carbon, the lowest locant. Numbering in this direction on the left is incorrect because it gives the alcohol the lower locant, and the alcohol is of lower functional group priority than the aldehyde. So again, really stressing that we think always about functional group priorities, and that comes first. So let's say that numbering in either direction gives you the same locant for that highest priority functional group, or you're dealing with an alkane. Possibly there's some alkyl halides present, meaning we have chlorines, bromines, fluorines, or iodines. Remember, those are actually just named as substituents, so they're not considered a functional group in the IUPAC system. If we're looking at molecules like these, we can just default to 2B, which is saying let's give the overall lowest locant set to the substituents. So let's look at two examples of 2B. Here we have a simple hydrocarbon, and we want to number in the direction that gives the overall lowest locants to the substituents. This is the incorrect numbering in red here, because it gives the locant 4 to the methyl group coming off that 6-membered chain. Here we have the correct numbering, which gives the lower locant 3 to the methyl group. Here's an example with multiple substituents. We have 2 methyl groups coming off a 6-carbon chain. The correct numbering is 1, 2, 3, 4, 5, 6, because we give a 2, 3 locant set, as opposed to numbering in red the incorrect way, which would give us a 4, 5 locant set. And we always want to default to the overall lowest locant set. And remember, of course, that comes after we give the lowest locant preferentially to the highest priority functional group. However, in this molecule, we just have an alkane, so we don't even have to consider that. Then, of course, if it's the case that numbering in either direction gives you the same locant set, if there's that tie in locant sets, then what we will default to is giving the lowest locant to the first named substituent. Let's look at an example of that. We'll call that scenario 2C. Here's a situation where you have a locant set tie. Numbering in either direction gives you a 2, 5 locant set to the substituents, and the correct numbering will give the first named substituent the lowest locant. Okay, so we have a bromo substituent and a chloro substituent. and accordingly, we would name this compound and number it in the direction that gives the first name substituent, the bromo substituent, the lower locant. Let's just build that name real quick. We have a bromo substituent, we have a chloro substituent, we have an alkane, so ane is our functional ending. We have 6 carbons, so hex is our alkyl prefix. Let's build it now. We have 2-bromo-5-chloro. Let's move this over to give us some more room. 5-chloro hexane. That would be our name. And again, if there's that tie and locant set, it is the first named substituent that preferentially gets the lower locant, and we number in the direction to give that first name substituent the lower locant. So I can't stress enough, again, this idea of first considering what is the highest priority functional group, because when we take that mentality to nomenclature, we're able to solve and do nomenclature effectively for any functional group, even though right now you might just be starting with alkanes and alkenes, possibly alcohols. We consider that first, and then we default to the overall lowest locant set. If there's a tie in that locant set, then we default to giving the lowest locant to that first named substituent.